Hi, welcome back to my channel. My name is Gina. In this video, we are going to look at derivative of the inverse of trigonometric functions. We are going to derive the derivatives and we are going to look at 4 examples. So we are going to look at these 6 derivatives. Derivatives of arcsine, arccos, arctangent, arccosecant, arcsecant, and arccotangent. Let's start with the first one. Arcsine of x. To find its derivative, first of all, let's define the function as y. So y equals to the function arcsine of x. And since we have an inverse function, that means if I move the function to the left-hand side, I will get sine of y equals to x. Here I have an equation that includes x and y, and I want to find the y prime, because y prime is the derivative of arcsine of x. But the equation is not in the form of y equals function of x. I have an equation that includes x and y. So when we have an equation like this, we need to use the implicit differentiation. I have another video on implicit differentiation, so if you want to review the video, I'll put the link up there. The step for implicit differentiation is we take the derivative on both sides and assume that y is a function of x. So when we have derivative of y, we have to remember to use the chain rule since y is a function of x. So if we take the derivative on both sides, on the left-hand side, I have derivative of sine of a function. So I get cosine of the inner function. And remember to use the chain rule. So multiply by derivative of the inner function, which is y prime. And this equals to the derivative of the right-hand side. Derivative of x is 1. Then I isolate for y prime. Y prime equals 1 over cosine of y. Now let's write the cosine of y in terms of x. Let's start from this equation here. I have sine of y equals to x. Y is inside the sine function, so let me call this angle y. And the sine function is opposite divided by hypotenuse, and that equals to x, which means opposite is x, and hypotenuse is 1. Then I can use Pythagoras theorem. The adjacent would be square root of 1 minus x squared. So cosine of y, it is adjacent divided by hypotenuse. That is square root of 1 minus x squared and divided by 1. So 1 over cosine of y, back to here, it would be 1 over square root of 1 minus x squared. So now we get to the first derivative. Derivative of arcsine of x would be 1 over square root of 1 minus x squared. Now let's look at the second function, arccos. The approach is the same as arcsine. So first of all, let's define the function as y. So y equals to arccos of x. And we want to find y prime, which equals to derivative of arccos of x. Since we have an inverse function on the right-hand side, so if we do another inverse function, we get cosine of y equals to x. Then we use implicit differentiation again. On the left-hand side, we take derivative of cosine of y, which is negative of sine of y. And since y is a function of x, so we use chain rule. So multiply by derivative of the inner function, y prime. On the right-hand side, I have derivative of x, which equals to 1. So y prime equals negative of 1 over sine of y. Then I want to rewrite the sine of y in terms of x. So I also start from this equation here. Cosine of y, that means the angle is y, and the cosine function is adjacent divided by hypotenuse. That equals to x, which means the adjacent is x and hypotenuse is y. So the opposite must be square root of 1 minus x squared, which means sine of y, which is opposite divided by hypotenuse. So sine of y would be square root of 1 minus x squared divided by 1. So let's go back to the y prime. Y prime equals to negative of 1 over sine of y, which also equals to negative of 1 over square root of 1 minus x squared. So we just derived the derivative of arccos of x. That equals to negative of 1 over square root of 1 minus x squared. In the next function, arctangent of x, we use the same approach again. So let's define y as the function, arctangent of x. And let's rewrite the equation as tangent of y equals to x. So to find y prime, I use implicit differentiation. Derivative of a tangent function is secant squared. So I have secant squared of y times y prime, since y is a function of x. And that equals to derivative of x, which is 1. So y prime equals to 1 over secant squared of y. 1 over secant function also equals to cosine function. So y prime equals to cosine of y squared. Now let's find cosine of y in terms of x. So from here, I have tangent of y equals to x, which means the opposite is x, adjacent is 1. So the hypotenuse is square root of 1 plus x squared. So cosine of y, which is adjacent divided by hypotenuse, it would be 1 over square root of 1 plus x squared. So let's go back to the y prime. Y prime is cosine of y squared. That is 1 over 1 plus x squared. How about arccosecant? So let's define y as arccosecant. Then I can rewrite this as cosecant of y equals to x. Then I take the derivative. Derivative of cosecant function is negative of cosecant function times cotangent function. And since y is a function of x, so times y prime using the chain rule. And that equals to 1. So y prime equals negative of 1 over cosecant times cotangent, which also equals to sine of y times tangent of y. Now let's find sine of y and tangent of y in terms of x. So from this equation, we have cosecant of y equals to x. Cosecant also equals to 1 over sine. So cosecant of y is the hypotenuse divided by opposite. And that equals to x, which means hypotenuse is x and opposite is 1. So the adjacent is square root of x squared minus 1. So sine of y from the triangle, it equals to 1 over x. And tangent of y, using the triangle, it equals to 1 over square root of x squared minus 1. Then let's substitute them back to the y prime. I get y prime equals negative 1 over x times square root of x squared minus 1. So if you follow the same approach for the other two functions, you will find these 6 derivatives. We have derivative of arcsine, arccos, arctangent, arccosecant, arcsecant, and arccotangent. Now let's look at some examples.